let's go to the program here and define some. So let's say I'm gonna define a shape, something of type shape S equal new shape. All right, I can say S dot X equal, let's say 5 and 7. Oh, sorry. So X at 7 and 5 and Y at 7. Okay. Now I can also define a circle. And I can also say circle. So this is the object dot X, even though I didn't define X itself, right? It is inherited from the parent, but it is accessible as if it was defined in circle. Let's say 15. All right, and same goes with rectangle. So I'm talking about X and Y now, so all of them. I don't know, 3. Okay. So that's the subclass and aspect. I can reuse the code. In addition to that, I have direct access to what is specific to the circle. And I also have direct access to what is specific to the rectangle. So let's say the width 10 and height 10. Okay? Yes. Say that again. Instantiate using the parent? What do you mean? You can say, I'm not sure I understand the question. So you can say, eventually we'll do that. You can have a shape, and then in that shape S equal new circle. Is that what you're asking? Yeah, we can do that. We will do it in a bit. For the dot operator? I'm not sure I'm getting your question, but if you're asking about, okay, if I can say shape, use the reference shape and actually point to a circle object, that's what you're asking? Yeah, so we can do that. You see, axis X and Y is not a problem, but accessing the radius would be a problem because this is like a zoomed in. This, like when you define the shape for the reference to the parent, it's more like zoomed in. Okay, if you want to access what is specific to the child, you will need to cast it. Yeah, and then it would be okay. All right. Yes. Sorry. Yes, sure, I can explain that. So you see here, when you say shape S equal new shape, what happens here? 3 things, right? Variable that would point to something of type shape. We call it S. An object of type shape that has X and Y. So let's say address 1, 2, 3. And then the assignment that you copy the address into that, right? What happens if we do the same thing, but instead of saying shape S equal new shape, we say new circle. Again, 3 things, actually 4 things here. Because circle is a child of shape. Now this part we make as an object, a reference that would point to something of type shape. Here, there are two objects here because circle is a child of another class. So an outer object that is the circle that has an inner object that is the shape are defined. So here x and y, and here the radius. Now all of them are accessible from at the same address. So let's say 456. This is the address, and that's what you store here. The address. But because this is supposed to be something of type shape, it's not pointing at the entire thing. It's only pointing at the shape part of the circle. Okay? So if I use this with x, no problem. So I will put 5 here. If I say s dot y, no problem. It will put 10 here. Now, if I say s dot radius, that's a problem a little bit. Even though radius is defined under the object at 456, because this is a zoomed in reference, it can only see the shape part. Okay? Now, if I want to see the radius part, I need to zoom out a little bit. All right? So in order to zoom out a little bit, I need to cast it. So I'm saying that, okay, I know that this is supposed to be top point or something of type shape, but the shape is just the inner object of the bigger object that is a circle. Okay, so now when we zoom out, when we widen the reference or zoom out to see the outer object, we would be able to access the radius. Okay? Okay, so all right. So I'm gonna leave this as is like this, and then I'm gonna define another circle because I wanted to. So let's say this is C or circle 2. Okay, this is circle 2. Now, if I define the reference of the type of the circle itself, so it is already zoomed out, so I don't need to cast. So this is 2, 2, and 2. Okay. Now let's say we have a function that takes I don't know, so add shape. Something that adds shape to our canvas or something like that. So it takes anything of type shape, and then just add it. So I'm just gonna put a representative, like we added it to our canvas or something like that. So shape plus s2 string. Now we can override this to string. Added. Okay, was added. Okay, so now I can call this add shape and send it the actual shape that we have here is no problem. I can call it and give it the circle that is also another shape actually, but points to another object, an object of type circle. I can do the same thing with circle 2. I can do the same thing with rectangle. Okay, so now if I run this, so I just defined one function. This function can operate on any of these types. Yes. How to run file? So I just click on, are you using Visual Studio? Yeah. Okay, so I just clicked on this arrow here. Okay, so maybe we can look into that later. So you see, I defined one function that can operate on different types of objects because it does similar things. Okay. Okay, so a shape was added, circle was added, circle was added, rectangle was added. Okay, now this is very convenient that we don't have to redefine a function for every single child. And it is also nice if we can replace all that with one line. So we can put all these shapes in an array of type shape. So I'm gonna define shape array. So shape AR equal new shape. We have four elements here. Now each element in this array points to something of type shape. So a pointer like this. Regardless of the object could be an actual shape or a child of shape, right? So I can say shape array at 0. So let's say equals our S shape. Array of 1 equals circle. Array of 2 equal circle 2. I put them all in one array. All right, and instead of having to rewrite the function call, even the function call, we don't have to rewrite it. We can just put it in a loop. So I'm just gonna comment this out. So I can create a loop. What's this? So for shape in, for each shape S in shape array, I will just add shape. I mean, call the function and send it that object. So that should give us the same result that we expected here, but without having to repeat the code. Okay,